Hello, we're going to look at the area of a circular sector. And so basically just note that when we look at the area of a circular sector, again, this is dealing with section 6.1 also, okay? I think, yeah, 6.1. All right, so when we look at that, we're actually a sector, meaning a portion of the circle. And so the area, remember that the area of a circle is pi r squared. Okay, the circumference is 2 pi r, but the area of a circle is pi r squared. So when we look at the area of a secular sector, a portion, then we still have the pi r squared, but we take the portion of that circle. So that's theta over 2 pi. And when we simplify this, we get theta times r squared over 2. Okay, because again, this is over 1. You see that the pi's actually cancel out. So this is how we get this formula here. All right, so we want to look at an example. This is in your book. If you turn to page 475 of your textbook, and we're going to look at question 91. Then I'm going to go back to question 85, okay? So let's look at question 91. It says, the following problems ask you to calculate the area of a sector of a circle. See example 5. So looking at number 91, it says, find the area of the sector of a circle of radius 20 feet with a central angle of pi over 2. So what I did was I drew a picture. Okay, so I drew a picture so we can see that the radius is 20, okay, and the angle is pi over 2. So I shaded this right, the first quadrant. So it's pi over 2. All right, so basically we're going to use the formula. And so the solution, we'll look at the solution. We know that A is equal to r squared times theta, or theta times r squared, over 2. This is A. And so r squared is 20, so that's 20 squared. And theta is pi over 2. And so that's over 2. So again, we have to simplify this. So that gives you what? 400 times pi. Now, let me ask you something. Do you realize that this 2 really goes down to the bottom? Will that confuse you if I do that? I'm going to just leave it at the top for the moment. Okay, so let's just put over 2. That's okay. Over 2. So this, if we just deal with the top, okay, 400 over 1 times pi over 2 just gives you 200 pi. So let's go up here. That just gives you 200 pi over 2, which simplifies to 100 pi. And so now they want us to, well, find the area. So versus leaving it at 100 pi, then just compute in 100 times pi to get your actual foot squared. So when you put in pi in your calculator, 100 times pi, you should get 314.16, and then that would be feet squared. Okay, do you know why it would be feet squared? Because we're dealing with area. Okay, when dealing with area, okay, it's a unit times a unit, which squares it. So it's always in square units. Okay, so area is always in square units. Circumference is always in linear units. All right, so that wasn't hard. Okay, so that's dealing with that. But now I want to go back to question 85. Okay, so let me save this. Okay. All right, so now let's do a new one. And let's look at number 85. This is on page 475, number 85. So if we look at 85, okay, You do not have, they don't give you any numbers here, okay? They don't give you any numbers. But they do give you the radius. Okay, so we're dealing with a unit circle, and this is what they give you. Okay, so they give you radius is 1 because it's 1 all the way around. But now they kind of shade it. This is what they do. They shade, or can I just paintbrush it? Okay, yeah. So they kind of do it like this. So this is kind of a picture that you see. And let me go back to this. And then they have like a triangle, okay, drawn here. However, in the book, you can see that that's, we're dealing with special ones, 30, 45, or 60 degree angles, okay? Those are our special ones, our common ones. And so this, in the book, is more of a 60 degree angle. So we have that the radius is 1, and theta is actually this is 90, or if you put it in radian, it's pi over 2, and then 60 degrees more will be pi over 3. But if we just leave it in degree mode for the whole thing for right now, that's 90 plus 60, okay, which is 150 degrees. Now note that we cannot deal with it in terms of degrees, so we have to convert the degree to radian form. All right, so convert to radian. So you have 150 degrees, and we want to convert that to radian. So that'll be pi over 180. All right, so that gives you what? 150 pi over 180. The zeros actually cancel out. And then you simplify 15 over 18, divide 3 into each of those. So 3 goes into 15, 5, okay, pi, and 3 goes into 18, 6. So theta is actually 5 pi over 6. So when we find the area of the shaded area, again, we're using the formula r squared times theta over 2. In our case, r is 1, so that's just 1. So we're looking at theta over 2. So that gives me 5 pi over 6 divided by 2. So why not just put it like this, divided by 2, since we have a fraction already. Divided by 2, so that's 2 over 1. So when we divide fractions, you multiply by the reciprocal, okay? And so therefore, you get 5 pi over 12. And so now you have to figure out what is that going to give you. So compute, put in your pi, your numerical value for pi. So that'll be 5 times pi divided by 12. And so that'll give you approximately 1.31. And we're dealing with, well, it didn't say. So I don't know what the units is. So it's 1.31 approximately. Okay, so 5 pi over 12, or 1.31. Good. So this is dealing with the area of a sector. Okay. All right. So hopefully this has been helpful. If you have any questions, just let me know.